what we saw so far was, well, we saw, we could start defining a class, and we learned about this thing called the constructor initializer, and that's the code that we put that would provide any setup code we need for the particular class we're writing. So of course we were working on a circle, so what does the circle need to know? Well, it needs to know its radius. And we saw that we could assign the radius, like we create a circle, then we say, hey, circle radius, it's, we set it to 1. But we also saw we could add parameters to the constructor, so, we could just set it directly upon creation like this. One thing, so someone came to office hours and they pointed something out. As you're going, we are constantly adding to this class. We're not going to go along and go like, okay, well, I want everything in here, copy, go down, okay, now I'm going to do it here, and then the next one. Like, you're going to want to put this all in the same cell to make your life easier. So we're just updating or adding to the class as we go. So just watch what I'm doing and you'll see what I mean. All right. So there we go. And let's just rerun everything we had. Oops. Is this at the back? Can you see this reasonably well? Yeah, cool. So here's the class definition. Here's the constructor, initializer, that takes the parameter radius, and it takes the parameter it got, called radius, and then it assigns it to self.radius. And who remembers what self.radius, why we have that self.radius? Anyone remember what that whole thing was about? One person maybe does. Uh-oh. What do you say back there?
Self is the reference to itself.
Bingo. So, self is a reference variable that gets the object back to itself. So when we say self.radius, it's like, okay, the variable radius, but whose? Well, mine. So we always want to reference, we always want to get to an object's attributes through a reference variable. So like here, I'm accessing the circle's reference variable, or pardon me, I'm accessing the circle's radius by saying a circle radius. This is a reference variable to the circle. Give me your radius. Here, we're setting it, but we're saying, okay, reference to the thing, well, it's the self's radius, and then we're assigning the value that it has. So the self is there to be like, okay, circle, this is a variable. This is an attribute that belongs to you. It's not just some random variable that exists inside a function. Like if I wrote this here, and I hit run, this will create a variable called blah and assign the value 88 to it. But then as soon as the constructor's done running, that variable is gone. It doesn't exist anymore. It only exists for the lifetime of that function being called, the method here or the constructor. When we say self, that's how we say, like, okay, it's something that actually belongs to you, to this instance here. So when I call run, so think for a second. When I said circle 55, it takes the radius 55, and then it says, okay, this circle, your radius is set to 55, great. And that self and a circle will be aliases for one another when this is like called. I suppose not really, because a circle isn't assigned any value yet until after this is done running its code, but they will have been pointing to the same object. When I call circle with 77, okay, great, create another circle with the radius 77. But this time, upon creation, the self-reference variable will be pointing to the same object that B circle is. But they won't be pointing to the same object. They're two separate objects. Then I access both, hey, A circle, what's your radius? B circle, what's your radius? 55, 77. Why? Well, because we just set them there. These are very dull. I mean, so far, not a lot of interesting stuff is going on. Maybe you find this interesting, that's great. But all we've done so far is define the circle need to know? Well, a circle really only has one true important property. It's a radius. You might say, well, circles have diameters. Yes, but that's based on the radius. An area, well, that's based on the radius. A circumference, that's based on the radius. All I really need to know for a circle is its radius. So, if you want to know the radius, we'll just ask the circle. If you want the circle to tell you what its circumference is, or its diameter is, or something, we need to ask the circle to do that calculation based on its radius, and then give it back. So where radius is just an attribute, the radius is, okay, just tell me this fact about yourself. When I say, give me the circumference, give me the diameter, give me an area, whatever else you want to add there, I'm asking the circle to do some number crunching and then get back to me. So there's the functionality. It's not just data, there's some functionality involved. Some number crunching. So the circle class has the attribute radius, but that's all it can do, is store a radius value. Maybe that's all you need it for, and if that's so, great. But you might also want to capture some other things, like, well, its diameter, area, and circumference. Fortunately, although these values are not stored in the circle does not have an attribute circumference, diameter, area. It doesn't. We can still figure all this out by doing some calculations based on the radius. So here's what I'm going to do. I'm going to add this right here. Be mindful that I am not simply copying this code and going down here, opening this up, pasting it, and trying to run it. That's not going to work. You will notice that I'm saying, like, well, okay, the init and other stuff is not shown here. I'm just adding this, and I'm letting you know it's part of the circle class. So I'm just going to copy this right here and dump it below here. Now, I need to be careful. There. I want the definition to be at the same level as the constructor. Very important. Because this definition belongs to the class, not the constructor. So it's going to be in the class at that same level as everything else in the class. So here we go. Right now, what I have is a function. But the function is, like, here's an interesting thing, right? So, like, it makes use of radius, but this function didn't take the parameter radius. It's making use of the circle object's attribute radius. So when I call this function, I'm not just like calling the function like print function or something. I would ask an individual circle to tell me what its circumference is. More on this in a moment. But what do I need to know for the diameter? Well, it's just 2 times the radius. That's all. That's all that I care about. This is here we've got it. Remember, all functions in the class start with a parameter called self. Why? Because it's always there as a reference variable to itself. And it's going to ultimately return a float. And what's it going to return is just 2 times the radius. So I'm going to run this. I'm going to go here. And I'm also going to print a diameter. Whoop, nope. $110, $154. Notice when I asked the circle its radius, there were no parentheses back there because it's just like a variable. It's just tell me your radius. It's the attribute. But with diameter, I needed to include the parentheses because it's not just like an attribute. It's a function. There's some functionality involved. So I'm actually asking Python to run the code inside that function. But we don't call functions that belong to a class functions. We don't call them that. We call them methods. If from now on in your brain you're like, screw that, I'm going to call them functions, fine, whatever. But we call them methods. They're a little different than a function because we don't just call the function, we actually have to call the function on a specific instance of the class. So when I ask, So you're going to say, like, but you never gave it the radius. But that's fine, because when I ask a circle, tell me your diameter, a circle, the reference variable that gets you to that circle, is very well aware of its own radius. It knows what it is. And if we go look at the original code that we wrote, well, it's 2 times self.radius. So 2 times my radius. And that's what I'm giving back. Any questions about that? All right. Yes?
So right now, in that, in line 1 and 2 of the second cell, you're just defining the radius by doing circle bracket.
Yep. Because when I call circle, it actually is calling this function right here, this method called underscore underscore init underscore underscore. It's just, it's a weird thing that we do in Python where if anyone ever calls the name of the class, Python knows, well, I'm going to call the constructor, the initializer, the init.
And can you have multiple init?
You can only have one. So, in Python, you can only have one. Other programming languages, you can have different things, but that's not a problem for us right now. And this right here takes the variable radius, takes a parameter radius, and so that's why when I gave it this value 55 here, it was smart enough to go, okay, well that's radius. Because we always just ignore the self whenever we're calling it as a parameter. Yes?
What's the difference between like a method and a function?
A function is, everything we've seen so far has been a function. A function that exists inside a class, sorry, let me say again. Every function we've ever written before is just a function. Whenever we write a function that's inside a class, we call it a method.
Why?
Because it's a little bit different, because we would ask an individual object to perform its method, where when we call a function, when we call the print function, I don't need to tell any specific thing to print, I just call print and I give it a parameter. So that's the differentiation. This is going to be something that's going to become a lot more clear as you go and you just practice a little bit. It is a funny little peculiarity. What I mean here is I can't just call diameter. There exists no function called diameter. I am not allowed to say, oh, print diameter. Because it's going to be like, well, that's not, I can't, diameter, that's not there. I need to ask a specific object to give me its diameter. I need to tell the object to do its method and get back to me whatever it needs to get back to me. Here, and just to really emphasize something, I'm going to get rid of these 2 lines of code here, okay? I'm just creating 2 instances. Right? I called the constructor twice. I called init twice. Even though you don't see me write underscore underscore init to call that, Python just automatically calls init whenever you call the name of the class. Because. And if you want proof that this code is running, right? So I added a print inside init. When I call the constructor, all the code inside this initializer, this constructor, is going to run. The first line of code is, well, assign the radius to be an attribute. And the second line of code is just print out I totally ran. So when I go down here and hit run, we see I totally ran, I totally ran. Why did we see it? Why do we see I totally ran 2 times? I made 2 instances, meaning I called the constructor twice. Once for a circle, and then another one for assigning B circle. Yes?
So for like the built-in methods that we already use, do those have classes of their own?
Now, which methods are you referring to?
Like append or something.
Append. So, append is a method because we're asking a specific list object to append it to it. Good observation. Same with strings. Remember how with strings, there's a bunch of methods with strings, right? You can ask a string to reverse itself, I think. There are a bunch of things. So that, maybe you can't ask a string to reverse, whatever. Strings have a bunch of methods associated with them. You could be like my string dot, and Python will show you. Let's show you right here, real quick. capitalize, case fold, center, count, encode, ends with, and these are all methods that are written inside the string class. We didn't have to write the string class, someone wrote it for us. Good observation, very good observation. Now I'm going to get rid of, okay, I already got rid of the print, so I'm going to rerun this there. So I added one function. We can add a couple more. I'm going to add area. Again, notice that I didn't include the constructor and other methods here just because I don't want this to get insanely long. I'm just going to take area and circumference, and I'm going to add it into the class. But I'm going to be mindful of at what level. Okay, good. I want it to be at the level of all the defs, so they line up. Now, in this particular case, I need to actually go, because I'm making use of math.py, so I need to import math. So I got to go back up here. I forgot to add this in the course content. There. Now I run this. Okay, great. So I imported math, class, circle. We have our constructor, our diameter, the area, which is just pi times the radius squared. Why? Well, because that's just what it is in our universe. Deal with it. And circumference, it's just 2 pi times the radius. Why? Because again, that's just how it works. Cool? That's it. That's it. That's all we need. So now, when I say, okay, let's make this a nice number, 10. If I say print a dot area and print circumference. I hit run. The radius is 10. Why? Well, I said it is. Its diameter is 20 because that's 2 times 10. The area is 314 point whatever the rest of pi is because, well, it's just 10 times 10 squared times pi. And then circumference is this because that's the result of doing that calculation. The key difference here is radius is the attribute. Notice, when I called radius, I didn't do this. There's no parentheses there. And if I do, it's going to be like there is no, like, I can't do that. The radius is just a boring old integer. It's just 10. Because the circle has the attribute 10. The circumference, the area, the diameter, those are all methods because there's functionality involved. We need to do the calculation based on the radius before I can get that value back. There. Now we've seen methods. We're adding methods to our class. Do we have any questions now? Because it's good, like, please ask me the questions. It's really boring just talking at you. All right, maybe nothing here is scaring you too much. But as you can probably see, this is kind of like throwing a wrench into everything you've learned so far. Like, this is a very different style of programming. It's not a function that takes a parameter. We're now writing methods for an object, and the stuff the methods are going to do are based on the properties of the current instance of that object. It's a little different. But everything should come together once we just keep practicing and learning more about it. Great. And here's example there, great. All right, in the above example, those are the methods are called with parentheses, yeah. Although the methods in the circle class have a reference self variable specified as parameter list, no, yeah, so this is saying like, well here, look, the method circumference, when you wrote it, it needed the parameter self, but when you called it, you never gave it the argument for self. Well, I know, you don't include those on the method calls because it knows about itself. It just does. Yeah, okay, when asking circle.area, I'm asking the circle object referenced by circle A to calculate and return its area. So there's some functionality involved. It's not just like just tell me, it's not a lookup of the radius, it's calculate the circumference, calculate the area, calculate the diameter, whatever it is, and then give it back after you've done that functionality. Okay. No, here's a note. Consider circle A dot area. The variable circle A is a reference to some circle object, and I'm asking for that instance to calculate and return its area. Here, circle A, when I say circle A dot area, like right here, it's going to go, okay, circle A area. So it's going to go and be like, well, that's this function right here. But here, self, in the context of right now, how it's being used, self and circle A are aliases of one another. They are referencing the exact same object. It would be like me telling, who wants to be the volunteer? You don't have to say anything, you just need to point at yourself. All right, you. Saw your hand first. It's like me saying, like, hey, you're circle A. It's okay, circle A, tell me your area, right? I don't care what your area is. And then you're going to be like, okay, well, in order to calculate my area, that's going to be pi times my radius squared. So you need your radius squared, so just point to yourself. And you'll be like, okay, whose radius? And then really emphasize you're pointing to yourself. There you go, right? So see how, like, his hand is pointing at him, and my hand is pointing at him. They're both aliases to the same circle object. Self is a reference variable to itself. So maybe that helped a little bit of getting a sense of what the hell self really is. You might say, well, what's the point? Well, we need a way in Python to differentiate between here's a variable that's just a variable, and here's a variable that really needs to exist and belong to a specific circle, and persist belonging to that circle. That's where self comes in. We'll also see some other examples of self that really help, I think, solidify the difference. It's a variable reference to the circle object. When looking in the area method's code, it makes use of the attribute radius, which is accessed via the reference variable to the instance of the circle object to the method it was evoked on. Self. Great. And now last thing we need to do here is, of course, we need to test our objects. Every piece of code we write, we want to make sure we're testing it. But how many of you have noticed, for example, on assignment 2, those assert tests I gave you started getting pretty chunky. They started getting pretty, like, there was a lot of, like, setup even. I need to create, like, the world, and then maybe alter the world, and then I can finally actually run the assert test. There was, like, a bunch of setup involved for each of the tests. They were getting pretty chunky and kind of hard to manage. And if you feel that way, you're right. The assert tests start to become less easy to work with as the complexity of our code grows and grows and grows. Assert tests are great when we have nice, simple functions. It's like, tell me the area, great, okay, great, right? So let's have a look at these assert tests. Okay, I'm just going to replace all this code here with the assert tests. I'm going to run them, and everything's happy, great. So these assert tests aren't too bad, really, because the functionality is rather straightforward. But, like, there's some setup. I needed to make a circle object, and then I can ask the circle its radius, diameter, area, circumference. So there's a little bit of extra work involved. Not too bad here, but it's not as simple as just calling the method or calling the function and looking for the answer. I had to do some setup. So here's a test for circle 0. It's always good to check the edge case. The edge case being like, well, what happens when you have a circle with 0 radius? Right? Well, if you do, its diameter should be 0, its area should be 0, its circumference should be 0. Great. And then a circle 10 should have all these values. And that's probably sufficient for the tests here because presumably if it works for a circle with area or a circle with a radius of 10, it's probably going to work fine for a circle with a radius of 1. You know, maybe I should have done a test that used a floating point number here as well to be a little bit more thorough, but I'm okay with this as it is. Also, do notice I'm using that trick here. The absolute difference is less than a certain value. Raise your hand if you remember why that's important. Uh-oh. Uh-oh. Do I need to restate the question, or am I becoming really concerned that you forgot a chunk of something we learned? Raise your hand if you have no idea why we're checking the absolute difference instead of equality. So now I'm confused because, so you don't remember. You do remember. Okay, you remember now. Okay, good. So I'm confused because when I asked who remembers, About a third of you raised your hand. Then when I asked, well, who doesn't remember, no one raised their hand. So I'm confused about the 2/3 that didn't respond. Let me just ask the question again. Maybe you weren't paying attention. Raise your hand if you remember why we're checking instead of checking for equality, I'm checking for this absolute difference being less than some value. Raise your hand if you remember why we do that. All right. So just to be safe, the reason that we check for an absolute difference instead of an exact equality is when you're dealing with floating point numbers, computers really suck with floating point numbers, right? And we saw an example of, like, was it 2 squared or something? So I can't remember what it was. What is 2 squared? No, shoot. There's a point earlier in the class where I have a decent example. Let's see if I can find it real quick. If not, I'll just move on. But I think it's around testing. Square of sums. Okay, here we go. Let's see, 2.2 squared. Yeah. Someone do a quick Google search for what 2.2 squared is. Just do it real quick. And then yell out the answer when you found it. 4.84. 4.84. Hold on, Python's saying it's 4.840000000000000001. I'm a little suspicious of what Python said here. Computers have a finite amount of information, but you might remember we talked a little bit earlier in the semester about how there's actually different kinds of infinity, which is a weird idea. The first easy one that I think we're all very comfortable with is countable. When something's infinitely countable. For example, we're talking integers here. And I ask you, what comes after 1? 2. What comes after 2? 3. What comes after 4? 5. Exactly. And if I ask you, well, what is the largest integer imaginable? And you say, oh, it's some number called n. And I'm like, no, it's not, because n plus 1 is bigger. Right? I can always just add 1. There is no end to integers. Integers go on forever, but I can put my finger on each one if I want. Because, well, 2 comes after 1, and 3 comes after 2. I can just always put my finger on each of those integers. The trouble is, as soon as we start adding decimals, we're in trouble. Now, Python is fine with, or computers are really happy with infinitely but countable things, because although, it has a discrete, there will be a limit on how big the integer that Python can handle based on the limitations of the computer. But Python's pretty happy with it because it's got these discrete bits and whatnot for keeping track of information that get decoded and all this, but it's very discrete, and so there's always these nice, clear differences between each integer. There's no ambiguity. 1 comes after 2. 2 comes after 1. And everything's good. But as soon as we have floating point numbers, we're in trouble. Because if we're talking about real numbers, what comes after 1? And you're going to say, oh, 1.1. And I'm going to say no, because 1.01 is between those two. And then you go, okay, is it 1.001? And I go, well, no, because 1.0001 could be between them. So when I ask the question, what comes after 1 with real numbers, your answer is I can't really answer that question. There's not an option. There's still an infinite number of numbers there, but it's like a totally different kind of infinite, right? Because there's like an infinite number of numbers between each number, on top of the fact that there's like an infinite number. We're in trouble. So with your computers having a very finite number of bits in it, it has to use some tricks for representing floating point numbers, and sometimes it fails. And you get things like, oh, 2.2 squared is that, but it's not. So if I ask the computer, now I think Python will actually be nice enough to be like, they're the same number. Here, let's quickly check that. Real quick. Ah, there we go. So it's there. Perfect. So if I know it's 4.84, and I'm like, well, the answer, I know that 2.2 squared is 4.84, but Python's saying false. So if I wrote something like that for my cert test, it's going to fail. But it didn't really fail because the issue wasn't with your test. The issue wasn't with your code. The issue was with, well, computers suck with real numbers. Anything with a decimal is trouble. So what we do is we say, okay, look, we acknowledge that computers suck with floating point numbers. So what we'll do is we can just take the difference between these things, right? We'll actually take the absolute difference because we don't care if it's a minus or positive. We look for the absolute difference. Now, that absolute difference is really tiny, right? Meaning times 10 to the negative 16, which is even smaller than what Python displayed, right? Python displayed 4.84.0000001. I don't think that went to times 10 to the negative 16. I think Python was just being nice and displaying something that was even closer to the reality. Where that number there, it's like, we're not even close. Pardon me. I guess I should be careful about how I word that. Those two numbers, 2.2 squared and 4.84, are the same. They should be. But when I take the difference, I get a times 10 to the negative 16 thing going on here. That is a very itty-bitty number. As far as I'm concerned, they're the same. So I just check instead that the absolute difference between that is smaller than some threshold I care about. True. If the difference is smaller than some threshold you care about, we'll be fine. We're like, okay, it's small enough, great. If you then are thinking, well, how do I know what the threshold is? This really depends on your circumstances. Right now we're talking about programming for the sake of programming, but let's say I'm a chemist and I'm writing some code to do some analysis or something, and my instruments for measuring are only accurate to like a certain decimal point. Well, I'm going to be, like, if I only get like 4 decimal points, you know, and I see a difference like that, I'll be like, yeah, okay, I'm fine. Because even if it was, I wouldn't have known the difference because I can't measure that close anyways. Raise your hand if you have or are currently taking, you know, like introduction statistics. Really? Only like 4 people? 5? All right, well, let's take a moment and let me ask you. If I ask you, I have a coin. It's a fair coin, and I flip a coin. What's the probability of it landing on heads? There's an answer to that question. What is it? 0.5. 50% chance. If I have a 6-sided die, a single 6-sided die, what is the probability of it landing on a 1? 1/6. Good answer. I don't want to do that math. 1 in 6. Now, I'm going to ask you a question. But before you start thinking of an answer, unless you already know the answer, great. But before you start thinking of the answer, I need to specify something first. If I say, what's the probability of it raining exactly 1 millimeter today? All right? And you're going to say, well, that really depends. I don't know. It's kind of raining right now, but I haven't really measured, so I can't really answer the probability. Yes, you can. Who knows the answer to the question? What is the probability of it raining exactly 1 millimeter, milliliter, whatever you use to measure rainfall today? What is the probability of it raining exactly 1 unit? 0. Raise your hand if you feel like it's 0. It's totally 0. What's the odds of that? It's because the reason that we can say the probability of it raining exactly 1 is 0 is because did it rain 1 or did it rain 1.1 or 0.999999 or 1.0000001 or 1.000000001 and so on and so on and so on. Real numbers suck. as soon as we try to make them discrete, because we like discrete things, we like, 1, 2. As soon as you start adding decimals, humans get angry, computers get angry. So that's why in your statistics class, you never say, what's the probability of it raining 1? You would ask, well, what's the probability of raining between 0.99 and 1.01 units today? You always give it a range. And then you do like the area under the curve, integrating and all of that. So it's the same idea. That we've got an issue with how many numbers are between 0 and 1, right? That was a big tangent. So that's why we check for the absolute difference being less than some threshold we care about. Is a threshold like this good enough? Sure. Is a threshold of like this good enough? Sure. Whatever. I don't know. Just pick something that's reasonable. Now, it is possible that you are wrong and you just picked a bad threshold. But, whatever. I hit run. Great. Circle. All those tests passed because it didn't yell at me. Any questions about what we saw? We started defining a class. We described what the constructor was. We saw that we can create instances of the class. We call those the objects themselves. Those instances, we verified that they have the type circle. So it's like we created a new thing with a new type. We had the attributes for the class, that's the data. And we also had the methods for the class, that's the functionality. And it's all stored in that class. Like the class is where it's all defined. And if I make instances of this class, if I make 20 instances of this class, I have 20 unique separate circles. All 20 must have a radius, but the radiuses will be independent from one another. Your radius might be different than your radius, which might be different than your radius. And that's fine, you all have a radius, but the values can differ. Just like all lists have a length, but the length of each list will be different depending on how big it is. All right. Object 2. So we finished learning, yes,
Can I ask you a question?
absolutely. Where do you want me to go?
Back to the code.
Oh, my code.
Yes. How come when you call the circle you put like 0 and then circle 10? Is that just the digits you're calling?
This right here. So, pardon?
Next to it, the circle 0 in the brackets, yeah.
Well, what I was saying here, go make a circle with radius 0.
That's the radius.
Yeah, so I specify the radius 0, and then if the circle that I created has radius 0, and I ask, well, what's your radius? It better be 0. And if I ask you, what's your diameter? Well, it also better be 0. And what's your area? It better be 0. Your circumference better be 0. Then the next one, circle 10. Circle 10. Well, I made a circle with radius 10, and so when I ask, well, what's your radius? It better be 10. What's your diameter? Well, if it's 10, your radius is 10, it should be 20. So that's what that is. That's all. It's just, and it's the setup code for these cert tests. But as we go, the more and more setup code we need for our tests are going to get more and more bulky and annoying. But don't worry, we've got a solution for that. Other question? That was a great question. All right, so. Oh, went to the wrong one. Objects for next class, next. Okay. Objects 2. More on methods. So we looked at the methods, great. The methods we wrote so far were, I don't want to say like easy, but they were relatively simple. Like there wasn't a lot going on. It was circle, just tell me your radius. And it's just a little calculation, return the value. But just like functions, our functions can become more and more and more complex. They don't need to be these simple little silly little things. You know, they can be a little bit more sophisticated. So our methods could get more complex as well. And we're going to see some examples of that. Like maybe methods start to need parameters. Maybe methods start to need to call other methods or something. I don't know. We'll see. So we saw how to write classes, how to write and make use of a constructor. We learned about attributes, how to set them, how to access them, how to write and use methods, and how to make instances of the class. That's what we've seen so far. What we're going to do is we're going to just make more classes with more complex functionality. And right now, so we'll see objects interacting with another object. This is another big thing. So what we saw so far was I created a circle, and then I just assigned it, and I asked values about it. Great. Now what I want to be able to do is start making code such that I can have my objects interact with one another. Because right now, like, my code was create an object and I'm interacting with that object. What if I want to make two objects and have them interact with one another to do something interesting? For example, we're going to make a sphere now. We're going to make a sphere class to start defining spheres. Only because it's slightly more sophisticated than a circle. But like a circle, a sphere knows its radius, but we're also going to add more attributes. We're also going to add an x, y, and z coordinate to our sphere, because our sphere wants to know where it exists in a three-dimensional space. So I can have multiple spheres existing in the three-dimensional space, at least, abstractly. There is no real physical three-dimensional space, but I want to have a sphere with radius 1 exist at location 0, 0, 0, the origin, and maybe as a sphere of radius 10 exist at index 1, 2, 3 in the same space. And then I could ask questions. Hey, do these spheres overlap? Do they touch? What's the distance between their centers? Anything I want. That's what we're going to aim to do. So, a sphere class. In order to find a sphere, all we need to know is the radius. But with the radius, we can calculate the diameter, the surface area, which is like, the circumference but in free space, and volume, which is like the area but in three-dimensional, right? But we also need to keep track of where it exists. So the sphere isn't just going to know its radius, it's going to know its x, y, and z coordinate. Okay? That's what we need. With this information, we can start to perform more sophisticated calculations. How far away are spheres from one another? Do two spheres collide, overlap? There's nothing stopping us from adding additional functionality. I mean, after we finish going through the stuff that we're going to write in this topic, we can add more and more and more and more and more, but we're only going to cover what we're going to do here. So I'm going to go back here. Let me get rid of this. Let me get rid of this. So I've got my empty notebook, delete, 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 delete. Okay, starting fresh. So what do I need to start defining? So I'm importing math here. I'm going to plop it here, hit run. Great. So, class sphere. We're starting to define the class. Great. I've got my doc string there explaining what the hell a sphere is. Cool. Then I've got my constructor, that init. Init, anything inside the sphere, we want the first parameter to be self, the reference variable to itself. And then we're giving it 4 separate parameters. X, which is a float, y, which is a float, z, which is a float, and a radius, which is a float. So x, y, z coordinates and a radius. So that tells us how big the sphere is and where it is. That's it. So I ran this. Zero, 1, 2, 10. And type of, my sphere. So, I made a sphere at the index 0, 1, 2 for the x, y, z. And those values I picked are entirely arbitrary. I just picked them. The fact that they're 0, 1, 2 has no real meaning. It's just it doesn't exist here in the space, it exists here. Okay, x, y, z. There, it's just here, right? I just changed where it is. I can make it the origin if I want, and it has a radius 10. And then I print out my sphere, and it's saying like, well, you've got a sphere object at this memory address. Remember, we didn't specify that memory address. The computer just like, make it right over there. And then I said, well, what's your type? Well, it's a sphere. It knows its type as well. So I made a sphere with those values. And if you want to know, like, okay, sphere, what's your x value? Well, okay, tell me, what's your x value? It's 0. Let's get rid of these prints here. What's your y value? It's 1. What's your z value? It's 2. What's your radius? It's 10. What's your last name? What will it say? It'll say, what the hell's that? I don't know what that is. It doesn't have a last name. Good, I tried to trick you. If you want to, you can say, like after creating the sphere, I can say my dot x equals 100, and then ask what it is. So I set it to 0, and then immediately said, no, be 100. And then I said, okay, what's your x value? Well, it's 100 now. Why? Because I can. So we'll end here, and we'll pick up here tomorrow. See y'all later.